going to take a look at some properties of exponents today and simplifying terms that involve multiplying exponential terms or raising exponential terms to powers. So here's an expression that we'll be looking to simplify: x to the third times x squared. And before we get to the rules, let's expand this out and see what it means. If you're taking x to the third times x squared, well, one thing that we can do here is just expand those two terms out as far as what they mean. So x to the third, what that means is we're taking x times itself 3 times. That's just x times x times x. Now x squared, which we're multiplying that by, is really just x times itself, so x times x. So in simplifying this down, what we want to do is condense this all down into one term that has one variable. Instead of having 2 x terms, we want to have just one, or 2x factors, we just don't want to have one. So since these all have the same base, we can condense these back down, and there are 1, 2, 3, 4, 5 of them. And so x to the third times x squared is just x to the fifth. If we took a look at something like y to the fourth times y to the fifth, expand out the y to the fourth and you have y, you have 4 factors of y. Expand out y to the fifth and you have 5 factors of y. So expanding this, condensing this all back together into one factor of y, or one term, we just have to count up all our factors. We have 4 here and 5 here, so altogether we have 9. So taking a look at these two examples should reveal something about one of the important properties about exponential terms. When you're multiplying exponential terms that have the same base, you're adding their exponents. So x to the third times x squared, the shortcut way is just added those exponents and got x to the fifth. Y to the fourth times y to the fifth gave us y to the ninth. So that right there is the product rule for exponents. If 2 exponential terms have the same base and are being multiplied, then their exponents are added. In a general form, that would sort of go along the lines that x to the a times x to the b is equal to x to the a plus b. So whatever those exponents are, we are adding those together. Let's take a look at another type of a problem here that will involve raising a power to a power. So let's say we have x to the second power and we're raising that itself to the third power. Well, expanding this out, we have this base here of x squared. So x squared is a base because it's being raised to an exponent. So whatever's being raised to the third power, we have that 3 times. So we have x squared times x squared times x squared. All we did is we took this base, which is being raised to the third, and just wrote it out as 3 factors being multiplied. Then each of these exponential terms can be expanded out. So x squared, that's just x times x. That x squared is just x times x. And that x squared is just x times x. So all together in the end, now I have 6 total factors of x. So this can be condensed into x to the sixth. So x squared to the third power turned out to just be x to the sixth. Let's look at one more here. If we take something like y to the third and raise it to the third, well, we have 3 factors of y to the third. So that's y to the third times y to the third times y to the third. All we did is took this base of y to the third and wrote it out 3 times because that's what the exponent was. Now each of these will be expanded out, so that y to the third is 3 factors of y, that y to the third is 3 factors of y, and that y to the third is 3 factors of y. And so altogether we have 9 factors of y, so y to the third is, y to the third is y to the ninth. So taking a look at these again, we had x squared to the third and we got x to the sixth. Here we had y to the third and got y to the ninth. So that should reveal another property about exponents, that when you raise a power to a power, you are multiplying those exponents together. And that brings us to the power rule. The power rule says that if you raise a power to a power, then the exponents are multiplied. So x to the a being raised to the b is just x to the a times b. I want to take a look at one more type of a problem here that's going to involve multiple factors being raised to the same power. So let's say we had something like 2n raised to the third, and we wanted to simplify that and actually work out that power. Well, what that means is that's our base, 2n, so we have 2n multiplied 3 times. 2n times 2n times 2n, that's the base. We're just expanding it out based on that power of 3. Now, because multiplication is commutative, I'm going to take all these 2's and I'm going to multiply them first, and I'm going to take all those n's, I'm going to multiply them second. So all I'm doing is using the commutative property of multiplication to just rearrange this a little bit. So here, 2 times 2 times 2 is 8, and here n times n times n is n to the third. So 2n raised to the third is 8n to the third. So this takes me to the next important part of the power rule. If you have a term with multiple factors in parentheses being raised to a power, then every factor in there is being raised to the power. So the 2 was being raised to the third, and the n was also being raised to the third. If we take a look at one real quick, like 4 x to the second power, well, there's actually 2 things being raised to the second power there. We have this factor of 4, that is being squared, and we have this factor of x, and that's being squared. So if you square the 4, you get 16, and if you square the x, you get x squared. So the term 4x, all being raised to the second power, is 16x squared. Take a look at a few quick examples of combining some of those things together. Alright, so I have a few examples here, and we're going to simplify these using the properties that we've just learned. So this first example here, we have 3x squared in parentheses is being raised to the third power. Since we have 2 factors in here, we have 3 and x squared, both of those parts are being raised to the third power. So 3 to the third power is going to be 27, and x squared to the third power, we have a power to a power, so the rule is we are multiplying these exponents and getting x to the sixth. So 3x squared raised to the third is 27x to the sixth. On this next example, we have 9x to the fourth times 2x to the seventh, and we're just multiplying these two terms together, no power to a power here. Because we have commutative multiplication, the 9 and the 2, those can be multiplied together first. So 9 times 2 is 18, and the x terms can be multiplied next, and because we are multiplying powers with the same base, we're adding those two exponents, and 4 plus 7 is 11. So this all simplifies to 18x to the 11th. Finally, I have 5n squared being squared times 2n to the 9th. So this might take a couple of steps. So first, let's go ahead and square each factor inside these parentheses. So 5 squared is 25, and n squared squared, multiply those two exponents together, and you get n to the 4th. So we're taking that times 2n to the 9th. So we simplified the first half of this to 25n to the 4th, and just have to finish off the job. So we have these two coefficients that we can multiply first because multiplication is commutative. So 25 times 2 is 50. And then these n terms, we're multiplying those together. So we're going to add the exponents, and 4 plus 9 is 13. So this simplifies to 50n to the 13th.